Hello viewers, I am Maitli. Today we are going to see 12 Cbse Maths application of derivative exercise 6.5 question number 24. Let's see the question. Show that the right circular cone of least curved surface area and given volume has an altitude equal to √2 times the radius. So here we need to prove is the altitude, that is the height is equal to √2 times the radius. So we need to prove in a cone. The cone we know this is R, this is H and this is our slant height L. Here we need to prove H is equal to √2R and the given thing is least curved surface area. Whatever it's given, least or maximum, the minimum, we need to differentiate that. So here we are going to differentiate the curved surface area of the cone and the given volume is the constant one. Whatever it's given, this is the constant one. So constant term is equal to V and your formula is pi r square H. In this we want V as it is. So bring let's take H is equal to 3V by pi r square. We can take R square or H. I am taking here H. Now what we are going to differentiate is the curved surface area. Curved surface area is given as least, so we are going to differentiate Csa. Csa formula here is C is equal to pi r L. So there is no meaning of substitute H here because we don't have H, we have a L. So for that I am taking L to be L is equal to R square plus H square. So H square is equal to L square minus R square. If only it is H square, we can substitute this formula and substitute the L value, or we can write this to be L square equal to H square plus R square, right? So here in the place of L square we can substitute H square plus R square. For that I am going to square all the terms. So surface area, curved surface area, I am just squaring everything. In the place of L square we can write it to be pi square R square plus H square. And also for H square it can be written as R square plus, this can be squared and written it here, so it becomes 9V square by pi square R power 4. Now taking that pi r square inside, we have pi square R power 4 here plus 9V square. By this pi square, one R square get cancelled and the rest we have one R square here. So now we got our Csa in terms of R. Here V is the constant value, it's given that given volume, so V is a constant one. So in the place of R we are going to differentiate with respect to R. So this can be written as differentiation with respect to R. So R here, R power x power n is n x power n minus 1. The same way power will come in the front and power will be reduced by 1. If there is a variable in the denominator, the variable power will goes up and there is a change in the sign here. So minus 18V square and the power will be increased by 1. So it becomes R cube. Now we want a second differentiation. We need to find whether it's a minimum or a maximum. Here it's given it is a least. Least means minimum. Minimum means the second differentiation, everything to be a positive value. So let me differentiate this again. We'll see whether it's a positive value. So second differentiation, if I do second differentiation, here the power will come in the front and power will be reduced by 1. So 3s are 12 pi square R power 4 square minus here. As I told before, there is a variable in the thing, means the sign will change. If it's a positive, it becomes negative. Negative means positive. 18V square, 18 into 2, 18 into 3. Here the power will be goes up, it comes as a multiply. So 3 into 18 and power will be increased by 1. So no need to multiply and check. We know that R and V volume, everything will be positive. Here we have both have a positive sign, means we can say this to be the minimum. Minimum is the least. So the curved surface area comes here as a least without substituting the value of r or v, we can say this to be minimum because of the positive signs in both the values. Now to find the r value or the v value, taking the first differentiation equal to 0. So put d by dr c square to be equal to 0. If we take this to be equal to 0, 4 pi square r cube is equal to 18 v square by r cube. Now bringing this to this side, it becomes pi square 4 I take it down, or we can cancel 4 pi square r power 6 is equal to 18 v square. Here this we can be cancelled, 2 here 3 9. 2 2s are 4, 9 2s are 18. This can be written as 3v the whole square. I am taking the whole square because here in h we have 3v. So if I substitute it here in the place of 3v, I can substitute the value here, means it will be easy for us to cancel. So in the place of 3v, I am going to substitute the value of 3v. So bring this square to the side, it comes as root 2 pi r power 3 is equal to 3v. Here I am going to substitute in place of 3v root 2 pi r cube. Now substitute 2 in 3. So let me do it here. We have h is equal to 3v by pi r square. If I substitute this over here, we have h is equal to root 2 pi r cube by pi r square. So pi gets cancelled. Here 1 r get cancelled. H is equal to root 2 r. This is what we need to prove. We have proved this. So that's all with the sum. Thank you.